Impulse. When you are hitting a cricket ball, or say hitting a football which is moving, so the change in momentum, or you can say the force, is acting for very short duration, which is changing the momentum of the body, velocity of the body, because mass remains constant. The scenario here is that for a very small duration, a heavy force is applied. So we come to another variable or property in motion, which is the product of force into time. Force applied for certain time, and this time is very less, and which is causing the change in the momentum, because velocity is being changed, so momentum is being changed, and this is the measurable quantity, and this we call it as impulse. So impulse will be simply force into time, which is equal to the change in momentum, which is causing the change in momentum, and which is a very, we can say, a large force acting for a very short span of time. It produces a finite change in momentum, and this is called as impulsive force. This impulsive force, and traditionally they were put in ordinary forces, but as we know, Newtonian mechanics, they have no such distinction. Impulsive force are like any other force. The only thing is they are very large and they act for a very short time. Let us take an example. A batsman hits back a ball straight in the direction of the bowler without changing the initial speed, that it remains 12. If the mass of the body is 0.15 kg, we have to determine the impulse imparted to the ball. Now the initial momentum was m1 v1. The final is m2 v2. We know that the mass remains the same, so it will be simply, let us take mass here, mv1 minus v2. Okay, so mass is, we are finding the change in momentum. So this mass is 0.15, 12, ball is coming this side, now ball is going this side, so one will be 12, other will be minus 12. So 12 minus of minus 12, that is 12 plus 12, and that is multiplied by 0.15. So 24 into 0.15, this will give you 3.6 Newton second in the direction from the batsman, because batsman has hit this ball in the direction of the bowler.